complex zeros. That means there might be an I involved in some of these coming up, and who on earth would think to test as a test number something with an I in it? But you may have some I's coming out in the zeros if I use the word complex. First thing I want to point out to lead you into this, wonderful questions the students are concerned about here. See if I can find that for us here. That was, just a second, I was looking at it at the break. Here it is. Now, watch what's going to happen. At one time, I was a supervisor of student teachers. And many of you probably have had a student teacher in your high school or middle school or whatever. So my job was in the city was to go out, and they assigned schools to me. They said, Ramsey, go out to high school A, go out to high school B today, high school C. We have student teachers in those classes, and we want you to sit in the back and assess them. See what they're doing, how's the discipline, how's their handwriting on the board, how are the questions they're asking students. So I had a long list of things I would answer as I sat back in the back. And then I would, at the end of class, talk to the student teacher who planned to teach math one of these days, and say, well, I suggest you might want to do this. I might suggest your discipline's not very good. The students were all over the place or in the classroom doing this and that, and you were trying to teach and didn't ask them to sit down or anything. I saw one like that. She just do whatever. And she went on, she was just on the board doing her work. Students were just up in the class doing things. Things like that happen. So I walked in one day, sat in the back, and a student was close by, and she was doing this with them. So I think this is very, very appropriate to show you guys now to try to answer that question. Where do those test numbers come from? So guys, to find the complex zeros on the side here. This is from a middle school class, middle school algebra 1, I think it was. She, the student teacher, I remember this so clearly. She gave them that, middle school, solve that nice little quadratic. And many of the students who did, they knew what to do, and they quickly factored as you and I would, and quickly got the answers, in this case, of that. And we all smiled. I said, man, this class is good. And she had taught this before, and they had students some work to do. Well, the little guy who was sitting next to me in the back, same problem. And she had me to sit next to him when I walked into the classroom to observe her. She says, Ramsey, would you sit next to him? And I said, who? The kid in the back. And sure enough, he's way in the back there, and I don't like students like that. I prefer students up closer. But for some reason, he was in the back. So I sat down. He had no idea how to factor. And that's what she told me. She says, I don't know whether she's given up hope, which you never do with a student, on him, and that's why she had him in the back, which I hated to see him in the back by himself back there. But I was sitting back there, I struck up a conversation with him. And after the class did this, and they got these answers, I looked over to see what he was doing. Because she was paying more attention to all the guys who were getting the answers, like so many teachers will. They like those students who give correct answers. I'm one of those students who may need a little help. So that guy needed a little help. So he had the answers. So I thought to myself, well, she told me he's having difficulty factoring. I said, does he know how to use the quadratic formula? Oh, no. He doesn't know how to use the quadratic formula. He doesn't know how to factor either. So she had just sort of thrown her hands up, which I don't like to see with a student, but she had, and had sort of isolated him in the back. But yet, I sat and I looked over his paper. I said, you got those answers? He said, yeah. He said, I got these answers. did not have a clue to do this. Do this. He didn't have a clue how to factor. And I thought, whoa, 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 I am so glad I'm sitting next to you. I said, can you tell me what you did to get those answers? And he told me. And then you guys are worried about the test numbers. Look at this, what this kid, that sort of leads me into what numbers I test. He told me, he said, sir, all I did was, I said, what'd you do to get those answers? He said, I don't know how to factor. I said, yeah, your teacher told me that. I don't know how to factor. He said, all I did was, I went to the last term, the constant, and thought in my head, what times what will give me -6? And he said, like pairs of numbers, like 1 times -6, that's a -6. Or a -1 times a +6, that's a -6. 3 times a -2, -6. -3 times a +2, -6. He listed all that he could, whose product is that constant -6. And guess what he did of those 1, 2, 3, 4, 5, 6, I got 8 there numbers. He did that, and guess what he did to determine which of those would work? Guess what he did afterwards? He listed all those factors, and guess what he did afterwards to get the answer and didn't touch factoring? He was patient, and he took, very patient, he took each one of these 8 and plugged them in to see which of the 8 would satisfy the equation. And he finally determined that 3 and -2, which the class had gotten by factoring, he though did this and he took 3 back, plugged in, it worked. He plugged in -2 up here, it worked. And that's where those numbers came from. I said, really? He said, that's what I've been doing all along. I said, really? You just take that and just list what in your head, what comes what will give you that last number, that constant, and test them until you find the one that worked. He said, yeah, it's been working for me. And I smiled, gave him a compliment. I said, man, this is great. I got to tell your teacher about this. You don't know how to factor, but you know how to get the answers. And then I thought to myself, hold on now, I saw what he's doing. He was just doing something unusual, but it worked. Then I asked him to do this one like this. 2x squared plus 7x subtract 4. Now watch carefully. It's going to lead us to answer that question you guys had before the break. You and I would do this. We would do this. 2x, x, plus 4, minus 1. We'd factor. And quickly, with our factoring skills, say, Professor, my goodness. The answers are 1/2 and -4 if I have no mistake up here. And guys, I think that's it. Is it 1/2 and -4? Okay? So I gave him one, something like that. I said, I was sitting right next to him. I said, here, now try this one. So you know what he did? He did like he did on this one. He jumped right down to the constant, the end term, listed all the factors of a -4, what times what, like 1, -4, -1, +4, 2, -2, you can turn that around. Numbers multiplied together to give you a constant term of a -4 on the end. 1, 2, 3, 4, 5, only 6, right? And then he did what he did over here on this one. By the way, it worked here. He was very patient, and he took each one of these and plugged them in to the original. And I think he may have found -4 worked. -4 worked from the factoring, right?
Yeah.
What's he missing? 1/2. His little system would not give him the 1/2. Then he got all disturbed. He said, whoa, because he was so pleased with himself. And by the way, she had her class arranged so that all of the problems she gave had a leading coefficient of 1. I changed it for him on this one to a 2. And that threw it off. He could not just list the factors of that constant term and test and get the answer. Can anyone tell me what? That's going to lead to a theorem on a handout here. What this kid's thinking actually led to a theorem. He had no idea what a theorem was. Couldn't even spell the word theorem. But he had right there in his mind, he knew what he was doing. But it would not work, his little system would not work on the second one. What's the difference, guys, in this one, where his system will not work? It will not give you the answers. It may give you one of them, but this one gave you everything you wanted. What's the difference?
The coefficient.
The coefficient. The leading coefficient other than one, his little system will not work. Then all of a sudden he came up with, he and I together, he said, well, maybe we can make it work. I said, whoa, how are you gonna make it work? And he said, I'll take questions. Second. He says, Professor, I'm gonna list all the factors of, like you said, -4. Let me list them here, guys. 1, -4. We're gonna do something like this in class here shortly. 1, -4, -1, +4, 2, -2. Those were his originals, all the factors of that constant term, like he was doing in the other problem. And he tested, and sure enough, he got -4 to work. But 1/2, he had no clue how to get 1/2. Then guess what? I think our students' hands are going up. We can sort of adjust this and get the 1/2 that's missing right now, if, and I'll give you a hint. Can anyone tell me what would I have to do here with his thinking to adjust it to get the 1/2 to finally come out as an answer?
I remember these are called the possible zeros, and so you're going to do the top, which is all the multiple, or the factors, or what multiplies to make -4, and then you're going to divide it by what multiplies to make 2, which is the
Okay, I'll take that. I heard that. Tell me something else though that I could do with her thinking to adjust his method, just a minor adjustment, and it'll finally give his 1/2 that he's missing. Now keep in mind, he's already listed all the factors of the constant term. And you guys said what messed him up was I placed a leading coefficient of something other than 1.
Divided by 2.
Oh, that 2's got to come in. So what did we finally suggest, he and I? List now, underneath here, the factors of 2. I'm leading coefficients of 2, so list those factors. 1 times 2, -1 times a -2. Hang on, Lisa. Now I'll get you. Are those the factors of 2? Now, guess what? Now if you start testing, hey, look at this. He's missing 1/2 in his little method. Now, would 1/2, if I compare that to that, would the 1/2 come out? In fact, since I have this adjustment, there's this 1/2 coming out. Would the other two or the other answer that we got, we're supposed to get 1/2, and what was it, -4? Even -4 is -4 over 1. Would that also give the other one -4? Now, where are my test numbers coming from? We gotta do this, like the kid in middle school did. And then let's see what the test numbers are, and we got to test them, see which ones work. But now, at least we have an idea of where did those test numbers come from? Where did Olivia get -6? Where did a student give me this, that? Where did those original test numbers come from, Professor? I'll be here all day, randomly selecting. And I'll see you during winter session. I'm teaching winter session. Anybody interested? Oh, I love winter session. 6 weeks. 6 weeks. We do 16 weeks of work in 6. And when they ask professors who would like to teach that, I'm the first one to respond. I love the short sessions. Aidens are saying, Professor, 16 is enough for me, 16 weeks. I can't imagine 6. Lisa.
I'm just thinking about one method, like refactoring. Can we multiply the coefficient by the constant?
Are you ready to multiply this times this?
Yeah.
The leading coefficient times the constant.
Yeah.
In this case, get a -8.
But then we can take take the factor that can multiply by,
You might,
and then do grouping.
you might.
Yeah?
I don't wanna go there right now, because I'm gonna apply what he did in middle school somehow to this. Shortly here, and see what's going on. Now, I want someone to remind me before I jump in and do all the, hang on a second, all together. You and I were looking at where you said maybe I should factor or factoring would give me the other answer right quickly. I erased that, I should have left it on the board before I jump in and finish the class up tonight. What a class we've had tonight. Let me erase this. We're gonna be using his method. I keep on calling it the kid's method. Actually, it's a theorem named for a mathematician who showed us precisely why it works. Hang on. Tell me what that was. I had them stacked up.
Oh.
Yeah. And I'm gonna show the class. We had something here.
It was, P of X equals 2x third.
2x cubed.
2x cubed plus 11x squared minus 7x minus 6.
Now, hang on. I'm gonna point this out. There's all kinds of things you've got to be aware of when you do a test on this. I had previously this. And tell me, what did we test first that did work? We tested what? 1? And we did this by synthetic, they call it. 6, 6, and a 0. And then guys, before you took the break, I think I went down and tested another number. Okay. Now, if you're clever, and we are, we're clever. How many zeros was I expecting? 3. We've already found 1. 1 itself, that number 1 works. And we found 1 of the 3, now I'm down to 2. If I'm expecting 2 zeros, that's a quadratic. That means these numbers, leftover numbers here, I could have, before the break, say, wait now, if I'm expecting only 2 more zeros, which is a quadratic, those remaining numbers must name for me a quadratic. In other words, 2x squared plus 13x plus 6 is equal to 0. That will give me the other 2 zeros without additional testing. Because I think a student after that asked me to test -6. And you guys were concerned, where did -6 come from? Olivia said, test -6, Professor. I did. Now, without testing -6, this method says factor 2x, x, 6, 1. Split these up. Please tell me, I know I erased it from before the break. Was there another possibility that we tested over here, a -1/2?
Yeah.
It worked. And here's Olivia's -6. I love it when that works. What's the issue here? If I had asked you to start out with 4, maybe then x to the 4th here, then you'd be expecting how many answers? 4. What you could do if you found 1 of the 4, you can still write this thing out, but this would be a cubic. You'd have another term here, it would be a cubic, and that cubic may not factor as nicely as this one did. So you may have to do an additional synthetic on it. All kinds of things to watch out for here on this. Okay, now let's put all this together. Geez, this is one class. Mr. Park, are you enjoying this? Boy, that was enthusiastic. Okay, now, let's do this. On the complex zeros, I'm jumping right into it. We're going to finish up, except for one little part. Chapter 3 is going to be finished. I brought in, let me see if I have it here, there we go, handout. Here we go. And guys, I got to ask you though, before I pass this out. Okay, Lisa, I made sure the section numbers are on here, which sections these pertain to, and we're going to look at this. Okay, let's make sure I got all this straight here. Mr. Park, Guy, would you do me a favor?